Video for April 28th. Just going to be reviewing a few more systems of equations problems to get you ready for Friday's test. Let's go ahead and get started with a system of equations by graphing problem with problem number 1 here. So this worksheet's available on my calendar. You can print it out or just take notes on these problems or just watch whatever you think is going to help you the most. All right. So what I want to do is graph both of these equations. So to graph the first equation, I put a point at its y-intercept of -3. The slope, I don't see a number here, so it has to be a 1. All right, that 1 I can think of as a 1 over 1, which means go up 1, right 1. And now I'm getting all of the ordered pairs that make that top equation true. Now I got this half of the line, so I got to continue this pattern but backwards. So instead of going up 1, right 1, I can go down 1, left 1, and I can get more points that are on that line. Okay, you can connect those up. I'll connect them up in a second. Let's graph this other one. So its y-intercept is a 2, its slope is a 6, so I could try to go up 6 over 1, be way off the graph up here, or I could go down 6, 1, 2, 3, 4, 5, 6, left 1, and I'd stay on that straight line. All right, so the red line are all of the ordered pairs that make the first equation true. Let's make that a solid line. The purple line are all of the ordered pairs that make the second equation true, and they only share this one point right here. All right, this point right here, we need to name it. So I go back to the origin, I need to go left 1 to be right over it, so that means my first number is a -1, and then I've got to go down 4, so that means my second number is a -4. This is the coordinate -1, -4. I could also write x equals -1, y equals -4. All right, let's try it again with this one. So y-intercept of -1, slope of -1/2, so I go down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2. All right, let's dot in the other one, y-intercept of 3. We go up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2, and there we can already see our point of intersection, but it's nice to add in these lines. Let's see, I'll do the red one first, followed by the purple one. All right, and then the last step, you gotta name this point. Go back to the origin, I'm going to go left 4 to be right underneath it, so -4, and then up 1, so a +1 right there. Or I can say x equals -4, y equals 1. And let's go ahead and check this with one of the equations. Let's try plugging it into that bottom equation. Does 1 equal 1/2 of -4 plus 3? Does 1 equal -2 plus 3? 1 equal 1? That's a good way to double check. All right, solving by elimination. Here, I'm going to take a quick pause. All right, so solving with elimination. What I'm looking for is a zero pair. I don't see one. The zero pair would be two terms with the same variable with opposite coefficients. Now that I don't see one, I look for the easiest way to make one, and so I'm looking for multiples. 9 is a multiple of 3. So that means it's easy to make a zero pair there. All I have to do is just multiply this bottom equation by a -3, and now I'll have a -9x and a +9x. That's a zero pair. Let me just show that I'm copying this top equation by saying I'm multiplying by 1, so that won't change. 9x minus 4y equals 22. -9x plus 9y equals, every single term has to get multiplied by that -3. -27. Add them together. These terms now cancel out. This here becomes a 5y, and this here becomes a -5. Divide both sides by 5. Get y equals -1. All right, not done. I've only found one of my answers, so I gotta go plug that back in. I can plug it in wherever I want, so I'll just plug it in right there, easy spot. Now the equation is 3x minus 3 times negative 1 equals 9. Negative 1 doesn't look like a negative 1. Multiply this here, we get 3x plus 3 equals 9, minus 3 minus 3. 3x equals 6, divide by 3, x equals 2. And now I've got both of our answers, and we should double check by plugging it into the other equation. All right, number 4. Do I see a zero pair? No. Do I see an easy way to get one? Yes, I can multiply the top equation by 2, and then I'll have a negative 14x and a positive 14x. So after I do that, I get negative 14x plus 8y equals 28. And the bottom equation is still 14x minus 9y equals negative 21. Add them together. These cancel. These here become a negative y, and then this is a positive 7 divided by negative 1. Get y equals negative 7. Let's go plug that back in. Plug it right here. 14x minus 9 times negative 7 equals negative 21. 14x plus 63 equals negative 21. Subtract the 63 from both sides. 14x equals negative 84. Divide by 14. 84 divided by 14 is 6. So x equals negative 6. All right. Is there a backside here? No. Maybe we'll do one of these by substitution just to practice it, but let's see. Number 15. So again, trying to do elimination. In order to get a zero pair, I can multiply the bottom equation by negative 2. And just copy the top equation. And I get 16x minus 8y equals 16. Negative 16x minus 6y equals negative 44. Add these together. These cancel. And negative 14y equals 16 minus 44 is negative 28. Divide by negative 14, divide by negative 14. Get y equals 2. Plug it back in. 8x plus 3 times 2 equals 22. 8x plus 6 equals 22. Take away that 6, we get 8x equals 16. Divide by 8, divide by 8. X equals 2. All right, let's actually practice the double check with this one. So I'm going to plug them both into that top equation. 16 times 2 minus 8 times 2 equals 16. 32 minus 16 equals 16. 16 equals 16. It works out. All right, let's try to do problem number 8 with substitution, then we'll call it good for this lecture. If I'm doing substitution, I'm looking for a variable that can be easily isolated. I think I've spotted it with the y in the top equation. That y can be easily isolated. So off to the side, let me copy down that equation. Negative 3x plus y equals 17. I'm going to add 3x to both sides. Y equals 3x plus 17. And now I can box this side of that equation and plug it in for y in the other equation. So this came from the top equation, so it's got to get plugged into the bottom equation. We're going to use a set of parentheses when we do the substitution here. So negative 2 times parentheses 3x plus 17 equals 11. Negative 9x minus 6x. 17 times 2 is negative 34, so minus 34 equals 11. Negative 15x minus 34 equals 11. Add 34 to both sides. Negative 15x equals 45. Divided by negative 15. X equals negative 3. You can plug that back in. The easiest place to plug it back in is right here in our manipulated equation, because this will directly solve for y. So y equals 3 times negative 3 plus 17. Y equals negative 9 plus 17. Y equals 8. Alright, so let's just make sure that makes sense. This would become a 27. Minus 16 equals 11. 11 equals 11. It checks out. Okay, call that good for this lecture video. Have a good rest of your day.